Okay, so what I'd like to do in today's video is continue our discussion on Unit 4, the UI management in software design and development. So previously, we introduced a GUI framework, JavaFX, and we really laid out a lot of the features um, and a demo of what JavaFX provides to us as application developers. It's a really powerful graphic user interface tool for our local applications, for desktop applications. So typically, if you're going to build an application, you have either web apps, which if you're interested in that, they have a class, CSCI2208. I have many of my lectures on my YouTube channel, in fact, so you can actually see what that class is like, which is not dissimilar to what we're doing with Java, but instead of having our source code run locally on the desktop machine, it runs inside the browser. And those are usually distributed applications as well, because there's usually a client and a server component. So very much like you typically would have a graphics-based interface when you go and manipulate a web page or a web app, you can do the same thing for your desktop applications. So instead of being forced to run it from the console, this finally gives us the ability to have a windowed application that feels very much like a real contemporary modern application. So I'm going to continue our deep delve into JavaFX so that you can become comfortable enough with the architecture of it, comfortable enough with the various components of it, such that you can start using it to build out your own applications. And ideally, you could build out an application that you can then publish onto your repository and then share and share it with others. So for today's lecture, I'd like to go ahead and focus in on the JavaFX core components. And so the most basic core component will be the stage component. So a quick overview for today's lecture. We'll do an introduction on the JavaFX stage. We'll talk about creating the stage and showing a stage, and then finally set a scene to a stage, and then give the stage a title, give the stage a position, give the stage a width and a height, give the stage a modality, give the stage an owner, the stage style, the stage full screen mode, and finally keyboard events that we can bind to our stage, or at least listen to from our stage. So a quick introduction here is that a JavaFX stage, and again, it's going to be inside the JavaFX. There's a stage package. Inside the stage package is an actual stage class. So that represents a window in a JavaFX desktop application. Inside a JavaFX stage, you can insert a JavaFX scene, which represents the content that's displayed inside of the window. So the scene is inside a stage. Again, very strong with the theater metaphors, very much like game engines as well, actually. So when a JavaFX application starts up, it creates a root stage object, which is then passed to the start method. Remember, the start method is an abstract method in the stage, in the application. Inside of the application class, and that's an abstract class, we have to define our start method. That's the logic that tells our app how to start up, our visual app how to start up. Of the root class of your JavaFX application. Yep, that's what I just said. This stage object represents the primary window of your JavaFX app, and you can create a new stage object later in your app's lifetime, right? So you're not just bound to one stage. Now keep in mind, the stage isn't the scene. The scene is, you can have multiple scenes in one stage. That's where you move from one scene to the next, and that's the stage is the window. But you can actually open up multiple windows concurrently. And so we'll probably take a look at that. So in case your application needs to open multiple windows. So let's see what it looks like just to create a stage. So if you create a JavaFX stage object, just like any other Java object, you use the new keyword, the new command, and the stage constructor. So we have an example here, and it looks probably what you'd expect it to look like in Java, right? Where we can go ahead and create a local variable, save a data type stage, and then just invoke its constructor. Okay, so let's talk about showing the stage. Simply, a simple creating of a JavaFX stage object will not just show it. In order to make the stage visible, you must call either its show method or its show and wait method. So here's a quick example of what that would look like. So if we created a stage, all you've done is create this stage. Now, the idea is that after you create the stage, you can then set it up so that it has it has its scene in there, and the scene has all of its various components inside of it. And only then, after it's been set up and initialized, then you're going to invoke that method show to actually display it. Let's talk a little bit about what the difference between show versus show and wait is, though. So the difference between the stage method show and wait is that the show makes the stage visible and then exits the show method immediately, where the show and wait shows the stage object and then blocks, or it stays inside the show and wait method until the stage is closed. So it just depends on whether you want to have the show method immediately relinquish control, or whether you want to go ahead and maintain that. Okay, let's talk about how we can set a scene onto a stage. So in order to display anything inside of a JavaFX stage, you must set a JavaFX scene object onto the stage. So the content of the scene will then be displayed inside the stage, which is our window, when the stage is finally shown. So here's a quick example of the code here. So suppose that we have some kind of a layout. So we're going to create a vertical box. So we're going to make a new vertical box. Inside the vertical box, we're going to pass a label object. So we're just going to invoke a label object, and then we're going to give it the string a JavaFX label. So then by the time we're done, we will now have a JavaFX layout that has a JavaFX element, which is a label element that contains some text. Then I'm going to take that layout and I'm going to apply that into the scene. So I'm going to pass that when I construct my scene. So my scene actually has some content. And I'm going to save my scene into a variable. And then I'm going to create a new stage. That's the window. I'm going to save that into a variable. And the stage, once I have constructed it, once it's been instantiated, has a set scene method. So I can at any time set a new scene into the stage. Well, I'm going to pass that scene we created here into the stage, and then when I then call the stage.show method, it'll show that scene. So let's talk about the stage title. So you can set the JavaFX stage title via the set title method, and so the title is displayed in the title bar of the stage window. So just a quick example of how this looks. And then after we go through some of these basic properties, we'll take a look at a live example as well. So here, once we have instantiated a stage, there's a set title method. We can pass it a string, and that string will appear inside of the bar that's on the window, usually at the top of the window, the window frame. Okay, stage also has a position. So you can set the position, which is in an XY coordinate space of a JavaFX stage via its setX and setY methods. The setX and setY methods set the position of the upper left corner of the window represented by the stage. So this is true in almost all computational graphics work. Your origin point is in the top left corner. So that's what our position 0, 0 would be, which means that in the bottom, that would be whatever the maximum height is, and all the way to the right would be whatever the maximum width is. And so in the bottom right corner would be the maximum width and the maximum height. So you can really think of the way that the coordinate space in computer graphics works the same way that the indexing works in an Excel document, right? Like your first rows are at the top and your first columns are in all the way to the most left. So just don't confuse it with Cartesian mathematical coordinate space where you do it from the bottom left corner. Okay, so here's an example of setting the X and Y position of a JavaFX stage. So if we create a new stage, we can then call set X, set Y, and pass it some numerical values. And so it might be necessary to also set the width and the height if you do set the X and Y position, because the stage window might be too small with the default parameters if you set the X and Y. Okay, so since I mentioned the width and height, let's cover those as well. So you can set the width and the height of the JavaFX stage with a set width and set height methods. Here's an example of setting the width and the height on a stage. So if we built a new stage, there's a set width, set height. This will tell you how wide in pixels. This will tell you how high in pixels the stage will be. Okay, so now that we've taken and looked at width and height and position in terms of X and Y and title, and we looked at being able to put a scene into the stage, why don't we take a look at an actual example at this point? So here, let's go to IntelliJ. Okay, so I'm going to open up stage example. So here I have an application. It just shows a simple stage with a title, XY position, and width and height. So the primary properties we just covered, as well as a scene. We said, yeah. So I'm going to create a public class stage example. Now recall that any JavaFX application, since this is a part of a framework, right? And the definition of framework is it is some code base that is missing critical implementation, so it can't execute. And so we fill that missing implementation. So the missing implementation for the JavaFX framework is that it doesn't have a initial application class, a concrete application class that it can initially invoke and launch. So what our job is when we work with this framework is to define a concrete class so that JavaFX can then effectively launch it. And this allows us to define our own logic that binds to our app, to whatever our app's goals are, so that we can then render the necessary views and give the necessary inputs and controls so that we can have a visual presentation into our own app's logic, our own app's model. So we're going to create here for this demonstration a stage example and extend out the abstract class of application. Then what I'm going to do is I'm going to create a main method, and we're going to explicitly invoke the JavaFX's launch method. So we're saying this is going to be the launch point of our JavaFX application. Now, if we don't explicitly put that main method with the launch, it'll implicitly happen. But I think it's always nice to go ahead and have that explicit start point where we define that ourselves. Then we're going to override the abstract method of start that's in the application. This is what we have to define to say how our personal app is going to start up. So start requires an initial stage. And so JavaFX worries about constructing the initial stage and passing it into our own start method. So just as an example, we're going to create an empty V box. That's a vertical box. That's a layout that can be put into a scene that can have contents in it. We're going to pass that vertical box, that V box, into the scene constructor, and we're going to create a new scene, and we're just going to save that into a local variable. Okay, so now that we have a stage that's passed in, we're going to just set up all of that content that's inside of our stage. So we're going to set a title into our stage. It's going to be called window title. We're going to go ahead and set the X and Y position to be 250 and 250. We're going to set the height to be 200 and the width to be 200 of our stage. That's our window framing. We're going to now set the scene into our stage with this scene that we created here on line 21. And finally, after we've done all the setup work on our stage, we're finally going to show it. So I have created a example runner here. So all of the demos, I'm going to invoke the main method from here. So let me go to stage example. Yeah. And I'm going to call the main method from here. And I'm just going to pass it the arguments. Perfect. Okay, let's go ahead and run this and see what this looks like. And so it's compiling, it's building. And boop, boop, boop. Okay, there it is. And we can see, did you see where the position, the XY position is at from the set X, set Y? We can see that the width and the height is 200 by 200. We can see that the title is in this top frame right here, window title. And then we loaded a scene, but we put a layout on our scene, but then we didn't put any of the thing in the layout. So we just have an empty scene effectively. And then when I go and hit the X, it's automatically going to exit out my application. So here we could see, bam, and then it's execution finished. Excellent. And then I will remove this import from here just to keep this nice and clean. Maybe I'll keep it for now so I don't forget. Okay. Let's go back to the slideshow then. Now that we've seen all of these little examples we covered in one demo, let's talk about some of the other properties that we have inside of the stage. So we have something called stage modality. So here you can set the window modality of a JavaFX stage. The stage modality determines if the window representing the stage will block other windows opened by the same JavaFX application. So you can set the window modality of a StageFX stage via its init modality method. So here's an example right here, and this is actually a full JavaFX application that I have inserted here. So we're going to create a public class stage examples that's going to extend the application, that abstract class application defined in JavaFX. Then we're going to create our main method, explicit main method that invokes the launch method to launch our application, and that's going to be invoked. The launch is going to invoke the JavaFX to launch our application, which will then create a stage, and then it invokes our start method, passing that stage into the start method. So here, this is our primary stage, and we're going to set the title that says JavaFX app. But then what we could do if we wanted to is create a new stage, which will create a different window. And so when we do that, we can then tell that new window, that new stage we created, to initialize a particular modality. And there's 3 different modalities we might want to select between. And so I've listed them here, but 2 of them were commented out. So suppose we use modality application modal, and then we could show the primary and then call the show and wait. But what does this application modal do? Well, that means it will block all other windows opened by this JavaFX application. So you cannot access any other windows until this stage window has been closed. So if we create a second window, and if we initialize the second window, the second stage, with this parameter, a modality application modal, then the primary stage will be the one that has the focus. And you can't go to the second stage until you've closed out this first one. But that's not your only option. We also have the option to do a window modal. And so that option means that the newly created stage will block the prior stage, the previous stage window that owns the newly created stage. So window modal would force the focus to be on the new stage, and then we couldn't interface with the old stage until we're done or close out from the new stage. And then the final option, modality none, it means that the stage will not block any other windows open to the application. So we could toggle between the two stages simultaneously. So let's actually take a look at that in practice so that we can actually see what that looks like. So here I'm going to open up my multiple stages example. Here we go. And so just to walk through this, we have our multiple stages example that's going to extend our application. We're going to have our main method that launches our JavaFX app. Here, we're going to define our start method, and it takes a parameter, a stage. Here, I'm going to create a new vertical box. I'm going to bind that to a local variable. Here, I'm going to create a new scene, and I'm going to pass it that layout element of the vertical box, and I'm going to save that into a scene variable. Then I'm going to say, hey, primary stage, the thing I got passed in my parameter here, I want to set the title to JavaFX app. I want to set the height and the width 200 to 200. I'm going to set the scene with this empty scene, and I'm going to tell it to show. And then that's going to immediately launch the window, but then it stops. Then it moves on to the next thing. We're not doing show and wait, right? So then the next thing we're going to do is we're going to create a new stage. We're going to set the title of that new stage. We're going to set the X and the Y position of it. Then we're going to set the width and the height of it. And then we're going to tell that new stage to show and wait. So let's see what happens when we go and just run this. Oops. So here I'll just copy this, and then we'll go to my example runner here. And we will go ahead and call the main method here. And let me go to my context. Let's import this so we can go ahead and run it. And let's go ahead and run my example runner. So I can just easily run through all these examples very efficiently. Okay, so here is an example of two different stages at once, right? And so here, notice, since I didn't define any modality, the default modality allows me to click from one to the other, right? This one's highlighted, and now I can focus on this one, then I can focus on that one. And I'll close this, and I'll close that. Excellent. So let's take a look at something similar, but where we actually then use the multiple stages with the modality implemented. So let's take a look at what we're going to do here. So with multiple stages modality, that's going to extend our application, the abstract class of the application from JavaFX. I'm going to have my main method that just calls the launch in JavaFX, which will then create a primary stage and pass it to our start method. Inside of our start method, we're going to create a button element, and we're going to add some text into the button element that says, click me if you can. Then what we're going to do is we're going to set the on action. So we're going to create an event listener on the button. So the event listener is going to respond to a button click. So here, when the event, so when an event occurs, we're going to create a callback function. And so a callback function can be this anonymous function here. And so there's an easy way to create anonymous functions in Java. We can put a parameter list here, the same kind of parameter parentheses you'd normally have for a function. And then we're going to create what looks like an arrow that points to the left, right? The dash, and then it's the greater than sign. But think of that more like a arrow operator. So we're going to go ahead and then push whatever the parameters are through the arrow operator into this block of code. So we're going to open the block of code with a set of curly braces, and we're going to close the block of code with a set of curly braces. And then we can have any set of instructions inside of our code block that defines our anonymous method. So there is the ability to create anonymous methods in Java, or what are actually called functions. So let me take this moment to define function versus methods, because up till this point, you probably only have necessarily, at least in your academic experience, had just programmed in Java. So Java is strictly an object-oriented language. And the way that your code base is organized in Java is that your statements are all of your your statements are defined inside of methods, and all of your methods are defined in classes, and all of your classes are defined in packages. And so you don't have any other choices in Java, right? So all of your methods have to necessarily be in a class. And so that idea of a class having built-in behaviors, that's when we call those things methods. But if you've heard the term function before, a function is simply a method that doesn't exist within a class. So since we're defining a method here, but this method doesn't have any membership to a class, we would then call that a function. So if you ever wondered what's the distinction between a function and method, that's exactly what it is. If you're defining some behavior, if you're defining a function effectively inside of a class, then it becomes a method. Anyway, so this is just a way for us to define a free-floating method, or what I will then call a function. And so it's strictly, it gets registered to the event handler inside of JavaFX, right? And so when JavaFX sees that, hey, a click event occurred on the button, then it will respond by executing this block of code associated with it. Okay, then after that, I'm going to create a new vertical box. I'm going to pass it that button element we created. I'm going to save the vertical box. The vertical box is a layout element, and we'll have a lecture that talks about all the different JavaFX layouts that we have available to us. When we create our scene, we're going to pass that layout element, and inside that layout element is that button element, and inside that button element is that string, click me if you can, and an event listener that's associated with it. So if the user clicks on it, it's going to print to the console button clicked. Okay, then on our primary stage, we're going to set the title with primary stage. We're going to set the X and Y coordinates of where our stage is going to initially start up or be located at. We're going to go ahead and set the width and the height of our stage, so 500 by 500. We're going to add this scene into our stage with the set scene method. And then finally, we're going to show our stage. So show, as you recall, is going to display, and then it's going to move on to the next set of instructions. So here, we're going to create a new stage. It's going to be a new window. We're going to create a title that says secondary stage in modal mode. Here, we're going to give this a XY position of 300 and 300. Here, we're going to give it a width and height of 300, 300. And here, we're going to use that method init owner, and we're going to have the owner of this stage be the primary stage. Now, ownership between stages is really based off the modality of how we could define which stage should have focus if one is supposed to have the focus. And so here we're going to do the window modal. So remember, window modal in our example, let's go back to our slides. Okay, window modal means that the newly created stage will block the stage window that owns the newly created stage. So using the window modal means that the second window will be the one with the focus, and we won't be able to touch our primary stage. Okay, so after stepping through all that code, and then finally we're going to show and wait on that second stage. So let's go to our example runner here. And let's actually go ahead and we're going to access that class, and we're going to call the main method from here. And let me just go ahead and import this class into this other class. And let me run this, and let's actually see what this looks like in practice. Okay, so I had my primary stage, which is in the back. I have my secondary stage, which is in the front. I can interact with the secondary stage, right? And I'm going to put it over here. And now notice I can't do anything. I can't click that button, right? Because of the modality that we've set between the two stages. So here, if I go ahead and finally exit out of this stage, now notice I now am able to interact with this other stage after I'm done. So now I can click this, and here in my console, the event listener observed that I caused an event by pushing the button, and it responded by executing that block of code associated with that event listener that we set up along with that function that we had set up. So now it's going to do a system.out and say button clicked. And each time I click on it, it's going to do that same thing. Excellent. And then I'm just going to close that out. And perfect. I did this. Okay. Let's go back to the slides then. Yeah, so I had a question. Is that a Lambda function? And yep, that is. So there's several names by which these anonymous functions can be called. You can call them an anonymous function because they're not given a name, right? So it's just a function that has a parameter list and a method and a function body. But the common name that's most used for anonymous functions are Lambda functions. And it's Lambda functions because we define them differently than a normal function, right? Because there's no state in there. And so Lambda function implies, and it's actually part of a different programming paradigm. So in Java, typically we adhere to what's called the object-oriented programming paradigm, but there's another equally as popular paradigm out there, which is called a functional programming paradigm. So and just to give you a little bit of background information on this, in an object-oriented approach, which is what we've been learning, each object can have its own state, right? It can have its own set of instance variables, and it can have its own kind of methods that can change the state of its instance variables or share the values of its instance variables with other objects inside the software system. And those other objects can have their own states with their own instance variables and their own methods. So a different way of building an application is to prevent any of your application from having pieces of state associated with it if it's just a series of functions that, and especially high order functions. So you can have functions that pass other functions to it. And then what you're doing is you pass data in to essentially this chaining of functions, and it processes it into the final solution. And so then there's no need to maintain state in between the chained set of function calls. And that's what's called functional programming. And you could see functional programming requires us to pass functions to other functions. And so that's exactly what we're doing. So a Lambda function is most popular in functional programming. But as you can see, it's implemented even in object-oriented languages like Java as well. And it's very useful for being able to define things like an event listener where you don't necessarily need to create a class that contains a method. Before we had a Lambda function, which is the expression I showed you, the old way of doing that in Java would be to create an anonymous class. You just create a class, and that class would then have a method that was your event listener. But you could see that's a lot of overhead just to be able to define a behavior that you want to map to a click. And so that's where Lambda functions really shine at. Another name for it is also called an arrow function, and that's because the symbol that's usually associated with these anonymous functions or these Lambda functions is that arrow operator we saw. That allows you to illustrate this is the set of parameters or the set of inputs that are going to be imputed into this block of code. Good question. Okay, so we already saw stage owner in practice, but let's just go ahead and look at the slide involving stage owner. So a JavaFX stage can be owned by another stage. You can set the owner of a stage via its init owner method. And here is an example of initializing the owner of a JavaFX stage plus setting the modality of the stage to the modality window modal. And this is exactly what we just saw. Okay, another thing we can do is we can have stage styles. So you can set the style of a JavaFX stage via its style method. There are a set of different styles you can choose from, and I have all the names here. And again, these are essentially enum types. So if you might recall enums from your prior Java class, it's going to be whatever the name of the enum data type is. So this is stage style, and then you can access any one of the discrete values that are defined inside that enumeration or enumerated data type. So the set of values is decorated, undecorated, transparent, unified, and D. So a decorated stage style is a standard window with OS decorations and a white background. So that's going to be your default behavior. An undecorated stage style is going to be the standard window with OS decorations, but still with a white background. So here, the decorated has things like the minimize, the maximize, the close buttons. The undecorated is just going to be the standard window with a white background, but you're not going to get the ability to have your control options on there. You have a transparent stage style. That's going to be an undecorated window, but with a transparent background. You have a unified stage style. That's going to be a decorated stage, except it has no border between the decoration area and the main content. And then you have a utility stage, and that's going to be a decorated window, but with minimal decorations. Okay, so here's an example of how all of those would look. Obviously, only one of these is invoked. The rest of these are commented out. And actually, we can look at a quick demo of that too. So if I go here to, let's close out of these older ones. Okay, so if I go to stage decoration example, let's just take a look at this source code. So here we're going to extend application. We're going to define a main method where inside of our main, we're just going to call the launch method that is defined within JavaFX. And we're going to pass it whatever arguments we put into main. And then what launch does is it creates a initial stage, and then it sends that to our start method. So let's define our start method inside of our stage decoration example. We're going to create a vertical box element. That's a layout element, and we're going to save that to memory. We're going to create a new scene instance, and we're going to pass it our layout element, our vertical box, and that's going to create a scene for us, and we're going to save that into memory. From our primary stage, we're going to set the title to say this title is not visible. And then we're going to pass the scene into our stage using the set scene method. And then we're going to initialize the style of our stage to be decorated. And then we're going to show it. Okay, so let's go to our runner here. Let's get rid of this one. And let's go here. And let's call the main method. So let me do a quick import here. Okay, and let's run this. Just give it a few moments as it loads up. And there we go. We see we have a window, and this is what the decorated looks like, right? It's the default behavior where I can close it. I have the frame that gives me the title. Okay, so let's change this though. Let's go back to our source code. So every time I play around with windowing, it's changing my zoom controls to the top. It's kind of annoying. Okay, here we go. Okay, so here, let's do undecorated instead. So I'm going to initialize with undecorated. We're going to go back over here. We're going to run this, and we're going to see that what that's going to happen for us is, now look at this. We don't get that frame anymore. We don't get the controls. In fact, I'm going to have to stop it. I can't just close my application from the X because I don't have an X button. So I'm just going to stop that there. And that allows me to go ahead and kill that. Okay, so then what we can do is we can see what transparency is going to even be wackier than that, right? If I do transparent, we can see it creates just an empty kind of window there. Okay, let's stop that. Okay, let's go here. Let's use unified. Save that. And let's run that. And here we see unified. Now with the Mac OS, it looks different on a Windows machine than it would look on here. And you see we're starting to get our decorators back. I close it out. And the last one that's on there would be my my utility, which I'm not necessarily interested in spending too much time showing any more of these off. But that just gives you a quick example of how we can have the default like window aesthetics set. Okay, perfect. Okay, so you can switch a JavaFX stage into full screen mode via the stage full screen method. Please note that you may not get the expected result unless you set a scene onto the stage. So an example of doing that is just to set the full screen to true. And so again, we have a demo of that here where I can do the full screen. And here I'm just going to create a vertical box. I'm going to set the vertical box into the scene, save the scene into a local variable. I'm going to set the title to full screen window title. I'm going to pass that scene into the set scene method of my stage, and then I'm going to set my stage to be to full screen true, and then I'm going to show it. Okay, so let's show this off. Let's do main. There we go. And let's go ahead and import this. And there we go. Notice here, I am now in a full screen mode. And let me exit out. And did that work for everyone on Zoom, just by the way? Was that captured? Excellent. It looks like it did work. Okay, and so the stage lifecycle event, so the JavaFX stage can emit a few events you can listen for, and these events are, and so if you're unaware, let me just give a brief description of events. So JavaFX applications run on top of windowed OS systems. So a windowed OS system is one that listens for events in and of itself. So if you're using a windowed OS, that could be either Android or iOS, or it could be Windows, or it could be Mac OS, or it could be some version of Linux like Ubuntu, right? The idea is that you might have icons that appear on your screen, and when you click on an icon, you can open it up, right? It'll launch a window that will then display the contents of that file. Or maybe you can double click on an icon and it will actually launch that application. So what's happening is the OS is an event-driven OS. So it displays graphics that are oriented graphically and positionally onto your display. And depending on how you interact with the display, with the graphics it's illustrating, it's going to respond. And so one of the awesome thing about windowed OS systems is they allow you to set up your application to listen for those events and bind your own behavior while your application's running. And so that's how we can access things like click events or keyboard events, right? That's given to us by the windowing OS system. And so it's an exchange of information between the OS and our application layer. Okay, so what are some of the events over the state of over the life cycle of our stage? Well, there's a close request, there's hiding, hidden, showing, and shown. Well, I mean, those are all the kind of buttons that we have available inside the window frame, right? Let's take a look at this. So to a closed stage event listener, so you can listen for the close events on a JavaFX stage. That means that you can be notified when the user clicks the button with the X on it in the upper right corner of the stage window. So listening for the stage close event can be useful if you need to do cleanup on resources after the main stage window is closed, or if you need to stop some threads or whatnot. So let's say, for instance, you have an application, you're writing to files for argument's sake, and the user decides to click the X button. Well, you have the option to do additional setup work or closeout work if they opt to close your application that way. So instead of the OS just silently closing your application, you can bind on the stage, set on close request. So that's when the X button is hit. This Lambda function, this arrow function, this anonymous function, where, okay, it always passes the event that triggered, that triggers on this basis, on the close request. And so what we would do here would just be to set like a message. So system.out.print closing stage. So in this sample, we would just print something to the console. Okay, let's look at some of the other events. So we have a hiding stage event listener. Here you can attach a stage hiding event listener to the stage, the JavaFX stage. So the stage hiding event listener is called before the stage is hidden. And again, that's essentially your minimize button, but after it has been requested to be hidden. So on the instance that they hit that button on the frame, you can do something like, in this instance, if you on the stage set the set on hiding and then a arrow function or a Lambda function, then you can pass the event. Obviously, you always want to put the event when you're doing an event listener, because JavaFX will always try to give you the event in case there's something in the event you need. Like, for instance, if it's a mouse click, the mouse click event usually has the XY coordinate of where the mouse was clicked at. So here we always want to have the event in there. Notice another thing you might not have noticed is, unlike with typical parameter lists, for a Lambda function, we don't have to declare the data type, right? We can just declare a variable. So when you see event here, that's just a local variable that can be accessible inside this code block, but we don't have to declare what data type that variable is. And that's very common with Lambda functions, where it doesn't have to be as well defined as, or as rigidly defined as our classical functions and methods. Okay, let's see here, some more of these events. So we also have the hidden stage event listener. So here you can attach a stage hidden event listener to a JavaFX stage. And so the stage hidden event listener is called after the stage is hidden. So one is called when the request is made. The other is called after it's been hidden. And so here we can put stage is hidden as the system.out message if we were to test this out. And finally, we have showing the stage. So here you can attach a stage showing event listener to a JavaFX stage. The stage showing event listener is called after the stage is requested to be reshown. So this is like if you minimize and decide to unminimize it, but before the stage is shown. So here, this would be called set on showing, and then you would pass in a Lambda function. So notice all of the event listeners, the consistency here. And so all we're doing here is setting up the events for the corresponding buttons inside of our window frame. But clearly, this should be motivation that any event listener, anytime we set up a button, anytime we set up a form or toggle or anything where we're looking to get input from the user, the way we respond to that is with one of these Lambda functions that are designed to be an event listener. So that when that event occurs, and we register that Lambda function, that function to the observer to the JavaFX, which is observing or listening for events, it's going to invoke that function we bind to that event. And then we call that event handling. So we're listening for events, and then we handle an event with a function, with a method. We say, this is what you do when this event occurs. And then finally, that was showing. And then finally, you have the shown stage. So here you can set on shown, and this is after it displays. Oops. And so the last thing I kind of want to look at is the stage keyboard events. So it is possible to listen for it's possible to listen for keyboard events on a stage. That way you can catch all the keyboard events that occur while the stage has focus. Has focus means that's the thing that's currently active. So we've seen an example where stage was blurred or not in focus, and we had multiple stages. Anyway, here's an example that listens for the escape and return keys on the keyboard. So let's look at this code really quick. On my stage, I can create an add event handler. And so here I'm going to put key event.keyPressed. So this is the key that this is the key event the event we're listening for is a key event, and the particular key event we're looking for, because this is an enum data type, is going to be when a key is pressed. So the first parameter here is what is the event that we want to try to handle. So what are we listening for in our event system? And then the second parameter is going to be a Lambda function, which is how we react, how we handle when that event occurs. So here we're going to have the same syntax we've been looking at. We're going to have an event, then we're going to have an arrow operator. So we're going to create an arrow function. And so inside the method body, so inside of this code block, which goes all the way until here, right? Because we're passing this as a second parameter to the add event handler. So here, I'm going to put system.out.print key press, and then I'm going to do a toString of the event. So we're actually going to see what the event is that gets passed in. And then we're going to do some things. We're going to make a switch statement, and we're going to get the code, the key code, essentially the keyboard code of the key that was pressed. So we're going to do get code. And so if it was a key code of 27, we'll close. Well, that's our escape key. So escape key is number 27 on our keyboard. Number 10 is the return key in terms of key code values. And here what we'll do is we'll update the width. So we'll take the primary stage, we'll get whatever the width is and just multiply it by 2. And if it wasn't escape and if it wasn't return, then we're going to print that that was an unrecognized key. Actually, let's do a demo of that really quick. So here, if I go ahead and I'm going to import my application, I'm going to import my scene from the scene package. I'm going to import from the controls a label, right? I'm going to import from inputs. So again, JavaFX has a scene package. The scene package has an input package and key events. The key events is a class inside of the input package. We have our vertical box. That's, like I said earlier, a layout. And we'll effectively go through presentations that go through all the different layouts, all the different inputs, and all the different controls, so you get a better understanding of all your options for JavaFX. Then finally, we're going to import our stage. Okay, so let's see what we're doing here. We're creating a new class, stage keyboard events example. It extends application. Main method launches inside of our start method. We're going to create a label that's going to have this text. The app will shut down automatically. Okay, then we have a vertical box where we're going to pass in that label, and that's going to be our layout element. Then we're going to create a new scene, and we're going to pass it our layout element. So now we're going to have a scene with a layout, and that layout has a label, and that label has the text. This app will shut down automatically. So then we're going to set our scene with, we're going to set the scene into our stage. We're going to set the width to be 300. We're going to set the height to be 100. We're going to show our scene. Then we're going to register to our stage. I'm going to show our scene, but we're going to show our stage is what we're doing. Then we're going to set an event handler on our stage. So the event we're listening for, the thing we're registering with the event handler, is going to be a key event. In particular, it's going to be a key that's pressed. And then the action we want is the one that I just described. It's going to be a arrow function, a Lambda function that will display what the key event was. And then if it was an escape key, I'm going to close. If it was the return key, I'm going to increase the width. And if it wasn't either, I'm going to get an unrecognized key. So let's actually test that out. Let's run over here and let's go here. Let's import. No, that's not what I want. Oh. Okay, let's run this. Okay, this app will shut down automatically. Okay, that's that label. So let's do G, for instance. So G, notice what I'm getting down here, unrecognized key. When I hit just the G on my keyboard, I'm going to hit the return key now. Notice that doubled the size of my window. Look, I can do it again. And then I'm going to hit the D. I get another unregistered key. And notice I'm also getting the printout of what that event object is that's getting passed into my Lambda function. So let's read some of the things that's printing out as part of the toString method. So it shows it's a key pressed event, key event, and then it's showing me where the source is, what the target is, what the event type is, whether the event is consumed, and it's showing me the text. So when I typed in D, notice it shows me the text of the key. I could also get the code, which gives me the code in uppercase, and that the text is in lowercase. I didn't do a shift or anything. So that just shows you some of the attributes that are inside this particular event. So if you ever want to know what's inside of an event, you can just do a system.out on it, right? And then finally, I'm going to hit escape, and that's going to close it out. And let's go back to our slides. Okay, and so that's pretty much everything that defines at least our stage. So we're going through the JavaFX core components, and so that's our most fundamental component. So if there's no questions about that,